Great. Well, thanks everyone so much for being here, and glad to be working with you this morning. I am Andy Pease. I'm an architect and lead accredited professional with Imbalance Green Consulting. And I'm here with Jennifer Rennick, who's also an architect and a certified energy analyst. And we're fortunate enough to be able to partner with 3C Ren to be able to bring you support, training, and coaching on the California Energy Code. So today we are talking about multifamily projects and the new energy code. So this is a standard slide. I think you all know how to use Zoom, but the point being, we are being recorded. You do get the slides at the end as a PDF and access to the video as well. During the call, feel free to put your questions and comments in the chat. You can raise your hand. And in fact, it's, with 30-ish of us in the room, if you want to just unmute and holler, you can do that too. Try to make it as interactive as we can, even in a virtual environment. I'm going to give you a brief overview of the 3C Ren program because Gray is a little under the weather. And so, but she's here in the Zoom room if you have any specific questions that she can help you out with. So this is an awesome program where 3 counties got together and said, hey, how PG&E and Edison have been using all our utility tax for their programs. Let's come up with something that's more specific for our targeted audiences. And so they came up with these 3 programs. The first is Energy Code Connect. It's serving all building professionals, designers, builders, etc. And it has 3 main services: Energy Code Coach. That's totally free. You can call or email with your targeted code questions, both for the Energy Code and Cal Green, and you get a quick response by Energy Code professionals. And we have training and support like this and regional forums. Excellent service. Building performance training, similar audience, but it's kind of throws a wider net in terms of those training options, and a lot of those are on demand right now. So you can anything from how to do heat pump water heaters to intro to passive house, insulation, any kind of energy efficiency kind of work. And there's also soft skills. So for workers, realtors, anybody who's trying to get into this business. And then finally is the Home Energy Savings Program. That's more of a direct install or incentives for energy improvements. Right now it's at multifamily and single family units. Again, cool program, go to the website and all of that. So did I miss anything, Gray? We good?
That was great, Andy. Thank you.
Sure. All right, today's learning objective is we're talking about the energy code and specifically the code changes. So the update process itself, and what are the things that are specific to multifamily housing and those changes. There are, if you registered with your AIA number, your ICC number, they'll report it automatically. But if you do need support in getting your learning units, just reach out to Gray and there'll be her email at the end of the program. This has been a 5-part series where we've 3 down. And so again, at some point, those will be back online. And in fact, we're offering them again after the new year, starting, I think, in January or February. Each time we do some updates, but there's always that opportunity. So today, multifamily, and then December 1st, after the Thanksgiving break, will be non-residential projects. So today we'll go over the cycle, how it's been reorganized, the high level changes, and then go into mandatory, performance, prescriptive. We'll have a section on alterations and additions, and then Q&A. So we'll save Q&A time at the end, but again, if you have questions as we go, we'll either interrupt or store them for the end. I'm going to go ahead and get started, and then when it actually gets hard, then I will turn it over to Jennifer because she's the brains of this operation in terms of the code. So here we go. As a reminder, the California Energy Commission is the one that's in charge of our energy code, and they do great work in trying to have us follow kind of our state's goals for energy efficiency and reduced carbon. So it's a 3-year process, tons of engagement in order to get to where we are today. And then, of course, they're already starting on the 2025 code cycle because that's just how we roll. So the big picture goal is that we're moving away from carbon as quickly as we can. So that's going to be all electric. That's going to be heat pump technology. And this is across the board for all the sectors, electric ready. So while we transition away from the fossil fuels, that everybody's ready to go all electric, more PVs, more batteries. So we have more resiliency in our energy grid. And we're also conscious of our health, indoor health requirements and strengthening ventilation standards. So the homes and businesses use nearly 70% of California's electricity and responsible for a quarter of California's greenhouse gas emissions. So as we clean up our energy grid, if we can go more electric and away from the gas, then we're on track to help support climate action. This particular presentation, because we are Tri-County region, we're going to focus on the climate zones 4, 5, 6, 9, and 16, which you can kind of see are the areas that were here in our Tri-County region. There are 16 total, and we'll kind of touch on them as we go. There's big exceptions. So key thing you need to know, new code goes into effect January 1st. So if you want to get a permit, that's the code you're going to need to comply with. You can download, have access to the code. Plus 3C Ren has a great resource library, so it has access to those energy efficiency standards. And that's also how you can get to the Code Coach program. So let's start off with how the code has been reorganized, because that's super relevant to multifamily. We had in the 2019, our current code, we have these 3 main areas at all buildings, then high-rise, residential, non-residential, hotel, motel, and then the low-rise residential. And what they did was they kept the all buildings section, and the non-residential still has hotel, motel, but then they pulled out the multifamily. So now we still have the single family section and the multifamily buildings section. That's where we're focusing today, is the new section. And graphically, you'll see we do some words, some graphics, because we all are visualizing this differently. So current code that's going out is basically we have the low-rise residential and then not low-rise residential. It was everything else. But you can see they have the chapters numbers, they are keeping the same. So chapters 1 and 2, and then the 3, 4, 5, and 6 is the non-res, 7 and 8 are the res. And so they're keeping those non-res, single family res, but now they've added chapters 10, 11, and 12. So here's our focus. So the high level changes in the multifamily is that there's performance method will use 2 metrics. It's actually 3 metrics now, right? It's and we'll get into that, but it's generally TDV, time dependent valuation, and source energy in a couple different formats. Dwelling unit ventilation, there's some updates there, as well as domestic hot water, space conditioning, some lighting changes. We'll touch on that briefly. Electric ready, so not required, and depending on your jurisdiction. Some, of course, are already requiring all electric for new construction. And then photovoltaics and PVs. And just, you probably recall that a lot of these changes, the code has a pretty reliable pattern of introducing new measures as potential credits, And then the next cycle maybe makes it mandatory. So the language will be familiar. It's just more things are required now than last time. And our presentation is organized by our 3 compliance areas. And they're color coded as we go through the presentation. So just to make sure we touch on that, mandatory requirements that's applicable to all projects. And then we go into the prescriptive component package. This is like a recipe card. So mandatory measures are still required. And it tells you line by line, walls, windows, insulation, equipment efficiencies, etc. It's a checklist approach. And then the performance method is where you do energy modeling. And so then you can trade off. You can go have more windows as long as your equipment is performing better, etc. So that's the modeling approach. And we'll use these colors throughout. So a few more terms. This is different than the single family, different than non-res. Each of those 3 sectors has slightly different language, but all kind of communicating a similar intent. We're using time-dependent valuation. That's what we've been using all along. That's about the cost of energy, meaning it relates to when is energy most expensive because there's the highest demand. So California is cognizant of our grid as a whole and how our buildings can be helpful or not helpful in helping manage that grid. And then there's a new measure, this total TDV, which includes all that efficiency that we're used to using, but it also takes into account the solar and battery contributions. And then this new performance metric called source energy that talks about carbon emissions. So a key takeaway here is that you've got to comply with all 3 of those areas. So energy efficiency, the total energy efficiency, and also in TDV, that includes batteries and solar, and then the source energy. I'm going to say the kind of the same thing, but in a visual form. So site energy is a term that we've used, and that's really about what happens at the building level, what says on your energy meter, and then but TDV takes into account the entire grid and when you're using your energy. And then source energy is this new term, a new proxy for carbon. And so when you start to get your Title 24 reports, it's going to show these 3 columns. The TDV is in 2 parts, the efficiency of the building, that has to pass. Then with the batteries and the solar, that has to pass. And then this 3rd category of source energy that is more dependent on, like, are you using energy at times when it is the cleanest? And we can talk about that a little bit more if there's questions, but the point is you have to pass all 3. So with that, Jennifer, is there anything you want to add, or did we cover that okay?
Oh, I think you covered that. That sounded good.
Good. All right.
There's some of us who could talk about that other stuff for like the whole time. So we're going to leave it that you pass
so good.
all 3, be done.
Great. All right, close enough. Here we go. All right, and I'll hand it over to Jennifer for mandatory measures.
Okay, thanks everybody. Probably big picture change worth mentioning for all occupancies. There has been some updates on equipment efficiencies, and mostly you're going to see that on the equipment that would be associated with non-residential spaces. So as it applies to multifamily, you might see it with the common spaces or the associated non-residential spaces that are part of your multifamily project. And a lot of the smaller pieces of equipment efficiency are still under Title 20. For this, I wanted to mention this briefly. The section is a reminder, it applies to all occupancies. And when a building is designed and constructed with more than one type of occupancy, So in this case, when we're talking about multifamily, you could have all your residential dwelling units, but a lot of times they're going to have the support spaces that are not dwelling units. And so depending on the size of your project, you may end up having like a low rise, small number of dwelling units in a multifamily project. You might still comply with exception number 2, which means that if your non-res spaces are less than 10% of the building, you can roll that into your multifamily calculation. And if those non-res spaces are less than 20%, you can still roll that into your calculation, but the lighting and other mandatory measures have to be applicable for each occupancy type. But a lot of times for larger projects, even if they comply with exception 1, what I see a lot of times is we just end up taking the project and running all the dwelling units under our residential occupancy and running all the non-residential part of the project under the non-res part of the compliance software for performance method. And this rule still applies. I wanted to point it out just because I think it's going to be important in your multifamily projects to realize that now the multifamily parts are still going to be complying with sections 160 and 160.9, which is the mandatory part of multifamily, but there's also going to be some other potentially applicable parts in the other sections of the code that are non-res. Okay.
So that's community rooms, gyms, offices, all those types of spaces that might support the residential, but are actually not residential units themselves, right?
That's right.
Yeah.
That's right. And under this new section for the mandatory measures for multifamily, I mean, this whole section is new. And so it's similar to how the other part of the code is set up. It's got the mandatory requirements. Then we're going to talk a bit about prescriptive, touch a little bit on performance in there as we talk about prescriptive. And then it's going to move into the additions and alterations. And this section is mostly addresses new construction, although the additions alterations section does refer back to some of these measures. And this is going to apply to the dwelling units in the common use areas of the multifamily buildings. And those non-residential occupancies in that mixed space will still need to comply with the sections 120 through 141 that are part of the non-res code. So it's cleaned up in that they pulled multifamily into new chapters, but there is some reference back to the other sections of the code for some of those non-residential uses. And the topics that are bolded here, we're going to hit on briefly to tell you what the highlights are for the new code change. So with ventilation and indoor air quality, and part of that, what Andy was saying about resiliency, better energy efficiency, but we're also looking at how to make sure that we've improved the indoor air quality of our projects. And the kind of the big picture change is that this section now addresses both the residential and the non-residential occupancies. So when you go into the code and take a look at it, and I'm assuming there are folks on the call who will at some point look at the code, or at least their energy consultants and their mechanical and electrical plumbing engineers will be taking a look at the code. And they're going to see that there's section that's specific for the low-rise residential, in other words, 3 habitable stories or less. And for HERS measures, they're going to reference you back to the residential appendices. And for spaces that are not the dwelling units, they're going to reference you back to parts of the non-res code, which is often repeated in this section. And for 4 or more habitable stories, they're going to send you to the non-residential appendices. And so we've lumped multifamily all together so that it's easy, I think, for people to find what they need to find for multifamily, but we still have this kind of bifurcation in the code that we had from previous codes, which is 3 habitable stories or less kind of behave one way, and 4 habitable stories or more behave another way. And we'll see that pattern kind of reflected as we work through this whole thing. So we're gonna hit mostly on the highlights because in a way we're kind of hitting non-res and res code all together, too much to cover in the time allotted. But hopefully I'll give you highlights of what you need to look for. So for the indoor air quality, which is talking about your outside air, fresh air ventilation, outside air changes. Part B of this part of the code still continues to use ASHRAE 60.2 for the basis for the dwelling units, the residential, and Part C references ASHRAE 60.1, which still continues to be the basis for the non-residential occupancies. And there's been a couple of key changes and some language added, clarification on central fan integrated ventilation systems. We'll hit on that next. Kitchen and bathroom exhaust, prescriptive ventilation duct sizing, and required ventilation with heat recovery and testing of those ventilation systems. So for those of you who are on our single family res, some of this may look familiar, but they've updated that also for our multifamily. If your project uses a central air handling system that also brings in the fresh outside air to meet that outside air requirements, the code basically added new language to clarify when and how you can use this type of system. And the main premise hasn't changed, which is that this kind of system may not have a continuous fan operating 24/7 to bring in outside air. It uses too much energy. So if your fan does do that, then your mechanical engineer and your installing contractor have to follow the new clarified rules on damper controls and variable ventilation operation and all the rest of the outdoor dampers. For the mechanical exhaust in kitchens and bathrooms, there's been a little bit of clarification and also some emphasis. I'm putting some emphasis on this, that local mechanical exhaust shall be installed in each kitchen and bathroom. And the reason I mention it is because many times, even now, after this has been in the code for a long time, we will still have some arguments with authorities having jurisdiction that and developers who don't want to provide exhaust fans for their kitchens. And they just use recirculating hoods. So that's not allowed. And we're going to talk specifically about kitchen hoods here in a minute. And however, if your kitchen is enclosed, you can use a continuous ventilation system that's part of an energy or heat recovery balanced ventilation system. And we have a picture of a slide looking up at a ceiling that's got a system like that I'll show you at the very end. That's part of the additions and alterations. But if you have an enclosed kitchen, you can do that. Otherwise, your open kitchen needs to have the demand controls and meet all the minimum ventilation flow and capture efficiency. And Andy's arrow, I see the arrow going, and yes, we very much need to remind folks that the occupant of the building still has the ability to turn the system on and off as part of indoor air quality. And the reason for that is kind of logical in the sense is that we have a lot of wildfires. And when those fires are at their peak and the outdoor air quality is very poor, the occupant has the ability to turn this ventilation system off. But otherwise, it should remain on to provide fresh air to the occupants.
And Jennifer, I always feel like, sometimes people get frustrated that they have this fan rolling all the time and it's the middle of summer and they have their doors open or their windows open. I mean, there is a certain amount of just individual control, but people have to have the awareness of what that fan is so that when the building is closed up, that they are keeping it on all the time, which frankly, most people do have their buildings closed up, right?
Right. Oh, and good point. In our Tri-County region, in our coastal climates, yes, many people have their doors and windows open all the time. And when your house is all opened up, like I do that when on the shoulder months, when the weather's just perfect outside, my whole house is opened up. And yes, I don't have any of these fans running. It's not necessary. Absolutely. For what's new to the code is an idea of having a kitchen hood efficiency, capture efficiency rating. And not all kitchen hoods have been rated yet, but many of them are getting rated. And the whole thinking behind having kitchen hoods with rated capture efficiency, and also in the code spelling out what kind of cubic feet per minute exhaust rate these hoods would have, is that we know that a lot of pollutants from EPA studies comes from cooking, comes from the gas range, and it gets into the dwelling unit. And very large dwelling units have a lot of volume. And so if you have cooking, it can be diluted throughout the space more. However, for small dwelling units, that are less than 750 area, for example, that capture efficiency over an electric range would need to be 65%. And over a natural gas range, it would need to be 85% or 280 CFM. And I'm reading off the bottom line on that chart. In this example that I gave here, if you have a capture efficiency rating of 55% on that particular hood, that means about 45% of everything that's coming off the stove is going into that space. And for this particular make or model that had the 55% capture efficiency, you could use that over an electric range. So it could be electric or induction range. And that would be okay for dwelling units 750 square feet or larger. But you would not be able to use that particular unit for cooking over natural gas ranges. You'd have to get a more powerful or a more capture efficiency hood. And other exhaust fans such as downflow still continue to be the 300 CFM or 5 air changes per hour for the enclosed kitchens. Anything you want to add on that, Andy? You're good at the indoor air pollution. Okay, then the other new thing on the code is that part of these mandatory measures is that you have to comply with either having that exhaust fan system tested, or you design the fan system where, for example, the duct length is no longer than 25 feet. The system has no more than 3 elbows. Duct system has an exterior termination fitting with hydraulic diameter greater than or equal to minimum duct diameter, et cetera, et cetera. So there's some specific requirements. And if you follow that, you don't have to have the duct testing. However, you can opt to have the system installed and then the installing contractor, or you could get a HERS rater out there to test the airflow on that equipment. And that equipment is not inexpensive. So if we have any builders on the call, this is one thing where you would want to know ahead of time if you're going to be able to have your kitchen exhaust system meet these requirements, or if you need to engage with someone who can do the testing.
Yeah, and this was an interesting discussion for those who were on the single family, because there was some thought about making sure that there's coordination from between the architect and the contractor, so that the contractor knows what's expected and when. Working with 3C Ren and as part of the Energy Code Coach, we're talking about maybe developing some standard notes for plans so that architects can provide the differentiation depending on how, and the mechanical engineer, how things were calculated.
Yeah, there's been a little bit of changes on the lighting, but not a whole lot. And it's mostly kind of a structural change in the code. There's been some minor updates in what's called the joint appendices, which is the part of the Title 24 Energy Part 6 code that we look at for what the efficiency, high efficacy for lighting, what that would be. And they've cleaned it up and made it more kind of in alignment with what is on the market, and also removed some of the LED light sources that were not high efficiency or didn't have a high enough efficacy. Took that out. They made some alignment with the electrical code. I did not put the actual language in this presentation for the electrical code. If you took our single family class, or you go back and look at that, I excerpted out, but it just basically is trying to say, hey, we're not going to dictate in the energy code what some of the clearances need to be for your recessed lights. We're going to just reference you back to the electric code. There's still the requirement for the blank electrical boxes. In other words, if your tenant, or for whatever reason, the interior designer on the project hasn't specified some of the lights yet for some of the dwelling units in this multifamily project, they repeated the part of the code that says you'd have to have electrical boxes, and not to have it more than the number of bedrooms, essentially. And those electrical boxes must be served by dimmer, vacancy switch control, low voltage wiring, or fan speed control. And then there's a section to specifically address the common service area lights for all the non-dwelling, like common living spaces and parking areas, outdoor lighting, and associated controls, et cetera. And it basically follows pretty much the same that you would see in section 130 in the non-residential section. And otherwise, there's some fairly minor changes in the lighting. For the electrical power distribution system, really, there is not too much change that what you would have seen in the non-residential section. It's just that now they've clarified that these same kinds of requirements are applicable to multifamily buildings. So minor changes and clarification that the non-dwelling unit portions of that multifamily project must comply with these requirements for separation of electrical circuits. So in other words, you'd still have all your sub-metering, electrical power distribution that goes to your, depending on the size of the project, your end energy uses. But that to be separate from your dwelling units. Still same code that you can't have a big voltage drop across your electrical system, and that there's a certain amount of receptacles and controlled receptacles that need to be addressed in the non-res. However, if it's a common use area that does provide provisions for living, eating, cooking, or sanitation to those dwelling units, then that's an exception. Probably one of the biggest changes to the code for the multifamily and the residential is the idea of having our projects be electric ready. And so under the previous code cycle, we had water heaters that serve the individual dwelling units. They must install an outlet that would be able to accept a future heat pump water heater and install the circuitry and have that designated on the panel. And now under the multifamily code, it's just clarified that for furnaces serving the individual dwelling units, similar requirements, so that could be swapped out in the future for a heat pump. And that if you have gas cooktop, that you would also provide for 50 amp circuit, 240 volt for future electric or induction cooktop. Same kind of requirements for dryers that serve individual dwelling units, and for the dryers, if they're gas, that serve your common space. So the new code doesn't say you can't use natural gas or propane in your project. It just says that if you do, you must supply the electrical infrastructure and provide the space in the panel and provide that within a reasonable distance to the gas appliance so that it can be swapped out for electric in the future.
I'm so curious about this, and it'll be interesting. Maybe during Q&A, folks can weigh in. I feel like this push requirement, especially in multifamily, that why would you use gas anymore? It just, you're already having to do all the wiring for electric anyway. So I'll be interested if folks want to, if they have comments about why there would still be in a multifamily housing, especially why folks would still integrate natural gas.
Yeah, it seems kind of odd that they would do it for the furnaces and the cooktops and all that, but I could see where they might have central water heating gas, which we'll get into next on the prescriptive measures, and might have a gas common dryer. But I don't know, we're seeing, it depends on the scale of the project, really,
Right.
when it comes to the water heating.
Yeah, well, and
Um,
that's a good point, because the if we are seeing more electric dryers, we do need to make sure that folks are understanding those ventless dryers and the air change requirements, et cetera, so that folks are successful with those components.
Oh, right. Andy's referring to a class we also did on that included the dryers. And so there's condensing dryers and heat pump dryers. And so they don't require that venting to the outdoors, which is could be a real benefit for apartments for sure.
But they do require air movement. So
Yeah.
you need both. All right, I'll quiet down again.
That's perfect. So I'm going to move into some of the prescriptive measures in the code that's changed. And I'll touch on performance as we go through, because a lot of times those prescriptive measures are the baseline for our performance computer method calculations. So in this new section 170.0, it is organized by topic A through H, building envelope, daylighting, conditioned systems, water heating systems, lighting, indoor, outdoor signs, photovoltaic for 3 stories or less, photovoltaic for 4 stories or more, and the battery storage system that goes along with that. Very few changes have been made in the envelope. And really what I'm going to do in the next few sections for the envelope, because I believe we have a number of architects on the class or on the call, I'm going to kind of highlight some of the changes, but there are not many changes. And it's mostly a blending of the residential and the non-residential, and now putting all this in one or several giant tables that you can look up the prescriptive requirements, which then become kind of the baseline that your buildings would be compared to. And for example, roof and ceiling insulation. Option B is known as attic, where the insulation is at the ceiling and or below the roof deck, and the ducts are in the attic. So even though we've got a new table, we basically have the same values from 2019. And just to give you an example, highlight like climate zone 4 up here in Atascadero where I am, the ceiling insulation at that ceiling level would require an R38, and under the roof deck, hugged up close to the roof rafters, snug up there, would be an R19. And for climate zone 6, where some of you folks are down in Santa Barbara, you would have to put in a radiant barrier. You'd only need the R30 insulation at the ceiling, and you can still run your ducts through the attic if you're doing a ducted system. Okay, next slide. And then if we compare that briefly for option C, it's still an attic, but now the insulations at the ceiling and the ducts are within the conditioned space. So you might have a situation where you've done a dropped plenum and small ducted system in there. For both climate zones 4 and 6, now you'd only need an R30 ceiling insulation and a radiant barrier. So it changes, and depending on your climate zone, it's also going to determine if you need to have cool roof or any of the solar age reflectance, which you get in the more extreme climates, which you do have, 10 through 15 would have some of those requirements.
Hey, Jennifer, Elijah's wondering, came in a question in the chat, if we're seeing many prescriptive path projects these days. I'm not sure, I mean, if they, well, anyway, what's your thoughts on that?
Well, the projects we get are like all performance. And one of the other calls for some of the ADUs, there were a couple folks, I think, on the call who found it easier in that case to do prescriptive in some instances. But for big projects, big multifamily projects, we're almost always doing the performance method. So the reason I point this out is because these features here is what your building will be compared to. So if you know you're doing ducts and conditioned space and you're in climate zone 4 or 6 and you go with an R38 attic, you just gained yourself some points to maybe mitigate something else.
Yeah, great point.
And then interestingly, when we were talking about kind of bringing over some of those low-rise residential requirements, we think in R values, but now for a roof that doesn't have any attic, it's a flat roof. Now, just pointing out, we're switching to U factors. And so that's one thing for the architect. You might need to make yourself a cheat sheet or look it up in the appendices on what kind of an assembly is a U factor that gets, 0.034, for example, for wood frame in climate zone 6. It's basically an R30 at the ceiling. But you're going to need to kind of think back and forth on these metrics. And
Bilingual.
yeah, bilingual. So I just want to point that out, that when you get in and look at these tables, you're sometimes going to be quoted a U factor or an R value, and mix and match. Okay.
Also have cool roof requirements within those.
Yeah, that's right. So there has been some update on some of the cool roof requirements, where straight across the board, it's gone to a more even 0.20 on your age solar reflectance, and a 0.75 on the thermal emittance, with just climate zones 1 and 6 not having those, 16 not having those requirements, but all the other climate zones now will have that requirement in addition to the insulation U factor we talked about. Climate zones are going to vary now by wall type and fire rating. And again, the wall insulation in this case is expressed as a U factor. And for framed wood walls, light mass construction, there's really no change. They've just added in a section now for metal framed buildings, any fire rating, or you've got framed, it could be wood, metal, and any other types with a greater than 1 hour fire rating. So those requirements are new. And then heavy mass, such as solid heavy concrete or solid grout CMU, that section is new now for multifamily, which used to not be part of the, the residential code. And for floors and soffits, basically no change, except there is a section now called other that is new. So if you don't fall into the categories, wood frame, the raised mass and all that, or 3 habitable stories or less for slab perimeter, and it's something else, that's a new section to apply with. Quality insulation installation required for new construction projects with 3 habitable stories or less. That part is an update, and it's in the code, but really here's where we have that kind of bifurcation, where it still doesn't apply to multifamily buildings 4 stories or more, but it's going to apply to 3 habitable stories or less, with the exception being climate zone 7. It's not required, but I did see, and this is where maybe at the end, our friend from the CEC could tell us a little more. I saw or heard that there's some talk about updating and looking into what this would take to do this kind of HERS on the projects that are 4 stories and more. So that might be coming up. On the windows, fenestration, fancy way to say windows and skylights. There's new performance criteria that's based on the window type and number of stories. Would you click the, just click all 3 of them for me. I don't think I animated them in the right order. Thanks. So for example, curtain wall, storefront is a type. So now if you've got a curtain wall or that type, then once you enter into the table here, then you figure out, okay, is this building 4 stories or more, 3 stories or less, depending on your answer. Then you read across the table and you go into your climate zone, and that's going to give you your solar heat gain coefficients, your calculated solar heat gain coefficients that includes overhang. And so this part of the table is more nuanced now, because you're going to be looking at this, if you're trying to get a handle on what's your baseline, what are you going to be compared to for your performance standards, this is kind of the basis for it. And it depends on your window type, depends on the size of your project, how many stories it has. There's a maximum window to floor ratio of 20% across the whole climate zone. And there's a maximum window to wall ratio of 40%. So you would calculate both of those, and whichever is less is going to be the baseline. And there's still a maximum skylight roof ratio of 5%, which is basically the carryover from the non-res standards. And this replaces a west-facing window allowance that we had in the residential standards previously. So now this applies for all the multifamily projects. Okay.
But it's just west facing, right?
Yes, there was a west-facing allowance that
'Cause it
said,
doesn't
oh,
even
you
say
couldn't
that.
have more than a certain percentage
Right.
of your glass facing west. That's not a requirement for multifamily anymore.
Right, okay.
And opaque door for exterior doors, just pointing out that, again, we're looking at how's the door used. We're trying to group all multifamily together. So is it a dwelling unit door? Or is it a common use door? Does it swing? Does it not swing? So that's going to determine the U factor on your door. And again, it's used as a baseline. And then their baseline for space conditioning systems, just the dwelling units only. We're going to look at whether the project, again, that bifurcation, is it 3 stories or less, 4 stories or more. But nice thing is you can find all your multifamily things in kind of one whole new section. And then depending on your climate zone, if you're in climate zone 1 through 15, which most of us are, the baseline is going to be a heat pump for our 3 stories or less, and climate zones 2 through 15. So they pulled out one, 4 stories or more is a heat pump. And there's an example of some wall-mounted heat pump from multifamily project. Balanced ventilation, so ERV and HRV. And the next slide coming up, we've got an example of what that looks like. And what's new to the code is specifically addressing energy recovery ventilation and heat recovery ventilation systems. And so the idea is that you would pull outside air into your house or into the dwelling unit to meet your fresh outside air requirements. And and then you would exhaust the air from inside the conditioned space. And these 2 paths of air would go through a thin membrane. It's a multi-channeled pathway. And the 2 air pathways don't mix, but the membrane is so thin that the heat and the energy can transfer between those airflows. And so for cold climates or very hot climates, this can be an effective way to save energy. But it's only an effective way to save energy if you don't have a lot of power going to the fans to operate them. So there's this like sweet spot of how much energy you're going to use for the fans and what the recovery efficiency of the ERV or HRV unit is. And so now the code is addressing those fan efficiency and ventilation recovery ratings. And it's based on climate zone, and it's based on whether the system serves an individual dwelling unit or if it's part of a system serving multiple dwelling units. And there's some new tables now that really address this in detail, which we're not going to go into. and I told Andy before this started, like we could do a whole day on just the mechanical prescriptive systems and tables that are now in the code. So if we have any mechanical engineers on the call, you're just going to want to go into this part of the code and just familiarize yourself with it to know what the
Jennifer,
baseline is.
is it also fair to say that that efficiency rating can make a big difference in the energy performance? So in the kind of your compliance path, so it's important to make sure that what's showing up in your Title 24 report aligns with the efficiency of the actual equipment being installed. I know that's true in single family, I assume.
I'm sure that is going to make a huge difference in the multifamily. And I haven't played around with that in the multifamily in the software yet, but I'm sure it's going to make a big difference because of our experience with it making such a big difference on the single family and the ADUs we had in the past, where when those two things didn't align, we had projects that were not passing Title 24.
Right. So the Title 24 had an overly ambitious efficiency rating than what was actually able to be installed in the field. And so then they weren't able to pass based on the rest of the compliance. So keep an eye out for that.
So this is just a snapshot of table 170.2K, just the mechanical component package. And then there's many, many tables that are going to deal with the sort of the fan efficiencies and other requirements for the mechanical system. And the main takeaway is that there's new tables. And this is just an excerpt to give you an idea. It goes into detail. Is it a MERV 13 to MERV 16 filter? Is it upstream of thermal conditioning equipment or downstream of equipment? You know, multi-zone, VAV, etc. So mechanical engineers, you're going to want to go in and look at that. And the architects on the call, I think you just need to know that this is something that's going to come up with efficiencies. Now, I went ahead and spelling out a little bit more on the domestic hot water because this a lot of times impacts the architect's design, because they're needing to make space and to understand if they're going to have hot water heating systems serving individual units or a big central system. And if they're going to serve individual dwelling units, you can still install individual gas or propane instantaneous water heater, kind of that is allowable, except remember, depending on your climate zone, that's going to determine whether or not it's part of your baseline. But what's acceptable in most all the climate zones is some type of heat pump water heater. Now, if you're in the really extreme climate zone, like climate zone 16, you need to have drain pipe heat recovery system added, or if you're not going to use a NEA rated tier 3 heat pump water heater, which these days I don't know why you wouldn't. All the ones that are readily available are tier 3 rated. You would have drain pipe heat recovery and compact water distribution. I'd recommend compact water distribution anyway, just because of energy efficiency and save some costs on the construction side. But there's two kinds of heat pump water heaters. One's an integrated and one's the split system. That Sanco unit, that split system, you know, visually conceptualized, you got an outdoor unit and a bunch of storage tanks. That's the same kind of conceptual method that's would be used for a central heat pump water heating system. Now, if you are going with a central domestic hot water heating system, you can use a heat pump system. And then there are certain prescriptive requirements now that are part of having that whole heat pump water system meet the prescriptive requirement for centralized system. I'm finding that all these bullet points, they were vetted by a lot of the folks at the CEC in the case studies that were specifically looking at heat pump water heaters. And that Sandco system that I just showed, that was one of the ones that was used in this type of system. So you'd have multiple outdoor units and they can be all plumbed in series, and then they go to a series of tanks that are your primary storage, and then there's a central loop tank that would be used to then distribute the hot water throughout the building. And it, again, for the architects, you need to talk to your mechanical engineers to understand where all this equipment's going to go in the space. You can use central domestic hot water that is gas or propane, and there are certain requirements for this, and namely, if you have a very large system and you're in climate zones 1 through 9, so that system's over a million BTU hour, then you're going to have a minimum thermal efficiency of 90%. For the smaller systems, you can take those on-demand units, larger scale, and sister them up and have them perform as a central system as well. If you do use gas, solar savings fraction, that part really hasn't changed. There is a assumed solar contribution that is associated with the climate zone. And maybe the only other change is that you don't have to have a dual loop recirculation system when you only have 8 units, 8 dwelling units or less. But otherwise, it's very similar to what it used to be.
And Jennifer, under the new code, the solar savings fraction, I know in an all electric building using heat pump water heaters, you can use PV panels as part of your solar savings fraction. Is that relevant going forward?
The solar savings fraction just kicks in on the gas or the propane heaters, and that solar savings fraction is like a domestic solar hot water, like solar thermal system for this. And if you have heat pump water heater system, it's a different, now we're looking at that.
You'll get the credit at the other one.
requirements.
Okay, that makes sense. Okay, got it. Thanks.
Okay, and then on the lighting, there really has not been much lighting changes. I'm gonna hit on a couple of them. And mostly the dwelling unit requirements match the single family changes, and the common area mostly match with the non-residential changes. Outdoor lighting has a minor calculation change, and sign lighting, really minimal changes. I'm not gonna spend a lot of time on lighting because the changes are minimal and it's nuanced in the sense that we've got new table for what your lighting power density values are. And this is like how all of the calculations for your non-res buildings were calculated in the past. And now what they've tried to do is when they create this new table 170.2, and this is just an excerpt, is they try to include categories that were appropriate for multifamily buildings so that it's sort of like all in one place. And there's just been a little bit of change on some increased stringency on the lighting levels. And for the outdoor lighting, still just a reminder, residential outdoor lighting controls apply to, if the lighting is attached to that dwelling unit, then you're going to have the control inside that dwelling unit. And otherwise, all the rest of the outdoor lighting is going to follow largely what we do for non-residential projects. For PVs, there is a prescriptive sizing equation now, And depending on if the project is 3 stories or less or 4 stories or more, will determine which equation you're going to use. And there's a definition now in the code for SARA, solar access roof area, and basically says you can use the roof of your structure, you can use the carports, you can use any of the roof area that's compatible for supporting the PV system. And one major exception is that if you have roof area that does not get enough sunlight, and the cutoff is 70% of the annual solar insolation. So what this looks like for a PV system for less than or equal to 3 stories, we printed the equation here for your reference. It's based on the number of dwelling units in a project. It's based on the conditioned floor area of the project, and it's based on your climate zone. And for this particular example, this was a project we worked on. It was under the old code, but we ran it under this new code just to give you an idea of what that would look like. And for this 27 unit, 3-story apartment building in Pismo Beach, we end up with a kilowatt PV system that is 38 kilowatt system required. And so they could get a reduction on that if they install the battery. I know for a fact on this project, we had plenty of roof area. So our SARA was far greater than 80 square feet. And the PV system size is greater than 1.8 kilowatts DC. So, and this system, I know from the exam, from having done this project, that 38 kilowatt system covered about half of the total roof area. And so even though it only covered half the total roof area, it was still a little tight because of shading, self-shading from the way the roof, the way the project was designed. And so we did work with the architect to kind of adjust where the panels would go and how they would be lined up, and adjust some of the parapets here and there, and where to put the inverters, et cetera, and the mechanical equipment, and they fit it. It all fit.
Jennifer, a question came up in the chat just to kind of clarify. There's been a lot of talk about, the new code requiring PVs, requiring batteries, but this is looking prescriptive change. So in theory, folks could use a performance approach and not install PVs, or is it just so weighted? And then just kind of previewing under non-res, is it also prescriptive change, or at some point is it mandatory but with exception?
Well, this is the prescriptive formula, and this formula hasn't actually changed for the 3 stories or less, because this was in the residential standards. So that's what I know. This project fits, and we did it. We worked on it. But so this part's kind of the same. What's different is the 3 stories or more, and there's no way that you are going to be able to get your project to comply without meeting a PV requirement, because you have to meet your efficiency TDV, then you have to meet the total TDV that includes a standard PV system layered on top of your standard efficiency. So the chances that you're going to be able to drive down your efficiency TDV so low that your PV system goes away, I don't think it's going to happen. And then you're not going to be able to meet your source TDV with that, because part of the PV battery and that source TDV is a proxy for carbon. Kind of the whole reason behind that is to try and get buildings, when the grid is clean and when we've got lots of PV power, we're looking at either charging batteries or using the electricity when our grid is the cleanest. And so it's just part of that overall strategy. There's like no way you're going to meet all three requirements without a PV system.
Thanks. And a time check here, it is 10:15, and so we've got 15
Okay.
minutes to kind of wrap up.
Yeah, and so for the 4 stories or more, the formula is slightly different. That's the main thing I want to point out. And it's an either do the formula or you look at 14 watts per square foot times that Sarah. And for this particular project in San Jose we worked on, we had a Sarah of about 12,000 square feet on top of the roof. So if we were to run this project under the new standards, we'd be looking at a system that's basically half of what the formula would require based on the 14 watts per square foot. So I want to point that out for your larger projects. For 4 stories or more, you want to calculate both, get a handle on your need, and then different adjustment factors for that formula. And for the battery, it applies to high-rise 4 stories or more when a PV system is required. So in that example, previous example, when that PV system is required, which it was, and I know the Sarah was big enough, you take that number of kilowatt PVs and you plug it into this new formula with these new factors based on actual batteries you look up. I'm not going to run through those calculations for you, but this is you'd work with your energy consultant or your PV consultant or your electrical engineer and run these numbers and give you an idea of what kind of battery size you would need. And for the additions and alterations, really some kind of minor changes, and this new section follows pretty straightforward format. Got your general requirements, additions, both prescriptive performance, then the alterations, which have its own kind of unique mandatory measures that reference back to the original, plus prescriptive performance. And then we get into a section on repairs and a section that deals with the whole buildings. And this is an important part of the section because there's a lot of existing building stock. Additions, the roof and ceilings, like the single family part of the projects, basically, there's been an upgrade for some of the climate zones from that R30 ceiling insulation for a vented attic to an R38. And so you got to look it up by the climate zone to know which one you're dealing with. And again, this is for additions, that are 700 square feet or less. And for the additions, for your indoor air quality, there's some clarification that junior ADUs don't trigger the indoor air quality. I don't know how applicable that'll be, but I'm sure there's a case where in a multifamily project, you do an addition, it's potentially possible to have a junior ADU as part of, maybe it was their caretaker's residence, and now you've got a junior ADU attached to it. Otherwise, a lot of these requirements follow the same as the single family requirements. And we have that mandatory measure for the kitchen and bathroom exhaust, local exhaust, that applies for our additions. Roof replacements. So if you're doing a remodel, rework on existing structure, it's important to know what's going to happen, what's going to trigger with the roof replacement. And when those roofs are replaced, there is a continuous insulation kind of R value that gets triggered for some of the roofs. So my recommendation is you know what climate zone you're in, you're doing a roof replacement, and then you need to come into the table 180.2A and take a look at if you meet any of the exemptions or what these new requirements are going to be. The alterations for ceilings of the vented attics. This is a new section, and it was new under the single family, and it's new under multifamily. And probably, I think one of the significant changes is that if you have an altered ceiling in climate zone 1 through 4, which is up here, North County, now it was shown to be cost effective that ceiling, altered ceiling, needs to be insulated to an R49. So it's higher than even the new construction. But part of the thinking behind that is the CEC showed that was cost effective way to save energy for these projects. Now, if there's already an existing R19 insulation, you're exempt. But if you get into a really old project, there's no insulation there. The prescriptive requirement is an R49. There's been a little bit of upgrade on the duct system. So if, again, you're doing that alteration and you have entirely new or a complete replacement of the ducts, this follows closely with the single family code. Now extended ducts, used to be you had to extend 40 feet. Now you only need to extend 25 feet, and it triggers this part of the code. Air leakage to the outside used to be 10%, but now it needs to test at 6%. And when I say test, duct leakage implies you're going to have a HERS rater out there to do that testing. Couple of the classes we were on, when some of the builder noticed that there was R6 for some climate zones, R7 for R8 for others, the thought was maybe they just would go with R8 all the time and not worry about it. But technically for certain climate zones, you can still use an R6 duct insulation. If you have an existing building that does have existing ductless electric wall heaters, even though the new construction, the baseline is heat pumps, you can, and typically you wouldn't be allowed to use electric resistance as the primary heat. You can in certain situations where that electric resistant space heating system is already there. And if it's located like in those milder climate zones like 6 and 7, it's there, you work on the project, you can use that type of heat again. May not be the cost-effective way to operate it, but it's inexpensive to install, and it's allowable if it was already existing. This is a new section also for alterations, specifically the ventilation for the dwelling units. So it does hit on those mandatory measures that we mentioned previously with certain air filters, kitchen exhaust, bathroom exhaust. So those apply. And if you're going to replace the ventilation system, and it's entirely new, or you have a complete replacement, and if you're replacing 75% of the ducts and the associated material place, that's considered a complete replacement. Then the new duct system also would have to comply with these mandatory measures. And if you're going to have a new system in place, this is what a dedicated balanced indoor air quality ventilation with heat recovery could look like. In this case, they ran 3-inch ducts throughout the ceiling of this unit, and there's a manifold that splits it off, and then the main ERV part of the main exchanger is located in a different part of the house, either in the garage or closet where you can get to it and change out the membranes if you need to and do maintenance on it. But they install super easy, and they're very straightforward and give the balanced ventilation with the heat recovery and low fan loads. So that, I'm going to turn it back to Andy, and she's going to.
Yeah, so we're thank you so much, Jennifer. I know it's super dense, and we'll go into the Q&A here, but just as a reminder, that you can, if you have questions, this Energy Code Coach, again, it's a totally free service, and you can email or you can call, or if you forget, you can just email Jennifer or me, and we'll take it from there and plug you into the system. And there's these continuing education units are available, as we talked about. Here's Gray's email if you have questions or need some different credentialing. And then we have upcoming courses still for the rest of the year, and a whole new round of courses being brought out for the new year as well. And so again, 3cren.org, super easy. That's kind of your go-to source. And I'll go ahead and stop sharing, and we can see if there's any additional questions. We did have one, Jennifer, that was asking for the PVs. If we have a kilowatt hour, do we have a kind of a guideline for square footage? I know those panels are maybe 400 watts, and they're, what are they, 4x8 now? What's the sizing that folks can do?
Okay, yeah, so the panels, it varies by manufacturer. And a lot of times what I'll do is I'll go online and just see, okay, what panel can I look at that, because it's a placeholder, because we know that it's changing, which panels are less expensive, which panels are US made, which ones are coming from China, who can get a hold of what right now. So if you don't have a PV consultant, or you don't have an installer on board, kind of real loose rule of thumb, you could use like 380 watts as a panel, for example, and that panel would be like 3.5 feet by 5 feet, you call it. And that just gives you like a rough rule of thumb. Sometimes I'll take that kilowatt and I'll just say, okay, I know that each one of my 380 watt panels is about 21 square feet. I'll sometimes just start there.
Right. And then of course there's the clustering and, minimum runs, how long of a run, and all those kinds of pieces that go with it.
Right.
Yeah, great. Any other questions, or anybody want to unmute and weigh in on anything? And then let's see, there was also kind of that a comment here about figuring out pitched roofs, and does that help when you're trying to do PVs? Obviously, if as soon as you do a pitched roof, if it's the kind of the wrong orientation, you're a little bit limited. And I know a lot of times in the multifamily, folks are trying to do some pretty fancy roof slopes and hips and valleys, et cetera. And so that further kind of reduces the PV area. So it does seem like we're going to need to be more intentional about our roof design, because that Sarah is about your sun exposure, but not about your roof pitch and hips and valleys kinds of things. Max, you have a question? Go ahead and unmute.
Yeah, sorry, a lot of this is just above my head. I'm a builder, developer, broker. So a lot of it's above my head, but just trying to get a high level overview. It sounds like there's the electrical upgrades to the panel and that type of thing, which obviously I think is better if we just went electrical rather than gas. But do you mind just giving a kind of a high level overview? There's the electrical, there's insulation, just to run through roughly what we're looking at that's changing, just kind of a summary if you could.
Yeah, Max, are most of your projects 3 stories and less?
Yeah,
Typically?
exactly. Yeah.
Yeah, so
even, I mean, I guess that's the threshold, right? 4 and 3 is typically.
it's still kind of a threshold, even though the code is saying, okay, let's lump all multifamily together. There's still that bifurcation with a lot of the requirements. So your projects are in that category of 3 stories or less. So mostly the envelope from the old code hasn't really changed. It's pretty much going to be the same. And you've got a PV requirement, which was under the old code, which pretty much was the same. And then your lighting that wasn't, attached to the dwelling units typically had to comply with the non-res part of the code anyway. And there's been a little bit of an update on how that's calculated, but I don't think that would impact your what you're doing, but your electrical engineer will know that and will have a slightly different formula for calculating your outdoor lighting for your parking lots, for example. Fortunately, there hasn't been big changes in that sense for the 3 stories and less. I think the biggest change is kind of a structural change to the whole code. And also, if you're doing projects at 3 stories or more, all of a sudden PVs and batteries are triggered. I mean, sorry, 4 stories or more, PVs and batteries are triggered.
Got it. So yeah, the batteries and PVs get triggered at 4 stories above, and they weren't before. Is that right?
Right. But since you're doing the low rise, 3 stories less, you already had PV requirements under the old code. And that stays largely the same.
Right. Okay, great. Thank you guys so much. Appreciate it.
Great. And it's,
I guess, sorry, one other thing. Baseline, under the old code, you could, the part of the new code is your baseline on your heating and cooling equipment. That's going to be the PVs and the electric ready. Those are probably the 2 big takeaways for the 3 stories and less. Think heat pumps and think electric ready, or just go all electric.
and it's 10:30. We'll stay on the call for a little longer because there are a few other questions, but I know folks need to get on with their day, so we won't be hurt if you need to jump off. Do look out for an email, a follow-up email. It has a survey. It's super helpful if you fill that out as well. But we'll stay on for a couple of these other ones. Jennifer, in the chat, we have some questions here. The difference between a heat recovery ventilator and an energy recovery ventilator. So that's kind of a question.
Okay, so conceptually, the difference is that there's some latent energy in moisture in the air. I don't know if that means, I don't know if that means anything, but when water evaporates, we're changing the energy in that system. And when we condense water onto a cold surface, we drop the moisture out of the air, made the air drier. So there's less kind of energy in that air. So the energy recovery helps to deal with the humidity and moisture as part of the system. And the heat recovery just does straight, like what you can feel, the sensible heat transfer.
And so in our climate zone, is it typically HRV, just managing the heat, or are you seeing both or more ERV? What's the?
I'm seeing for some
or
projects,
best practice, what would you like to see?
Some projects, some designers wanting ERV on purpose because they're wanting to dehumidify the air. But then I've heard in practice in our climate zone, because a lot of our climate zones are quite dry once we're not right on the coast, that it over dries the air. And so then the folks who are distributing and repping the equipment are trying to get a lot of us in our area to use HRVs.
Right. So, and Judy's weighing in that feels like the ERVs are most appropriate for humid climates, just kind of echoing what you're
right. So then some folks right on the coast in Santa Barbara, I had some folks say, no, we're getting an ERV. It's so humid, but it's cyclical humidity. So I don't know how appropriate it is.
Right. All right. A couple more questions here. I'm going to take them in the other order. The benefits of solar thermal for domestic hot water. I would kind of weigh in that strategically, we've really have not been advising installing solar thermal, that once you're doing a PV system, an electric heat pump, that's kind of the way to go. But what do you think for multifamily? Is there a opportunity if folks are doing a gas boiler that you'd still want to do solar thermal?
I'm seeing that it's really dependent on the location. So we've had projects in LA where it was very easy, and they had reps and they had the equipment and they had the installers, and they included solar thermal in their projects, and it was just not a big deal. But here in North County, San Luis Obispo, it's a really big deal. It doesn't happen because we're not having that many people who could install the systems. And for a long time, we had an Oregon company that was doing it, and they mostly have gone to, they were some of the first to switch over to heat pumps and PVs instead of solar thermal. But in the back a couple decades, that's what they used to do, with solar thermal with gas, high efficiency gas boilers.
Right. And then finally, and then we'll probably wrap up here, but there are a couple of questions about from David, I don't know, Subos, is that how we say your name, David? And I think your building department. Questions about junior accessory dwelling units. I know we have focused some content specific about ADUs, but do you want to unmute and ask what what your questions are about compliance in this context?
From a building code standpoint, a junior ADU can have access to the main dwelling. There's no requirement for fire separation. There's no requirement for isolating the electrical. So really, aside from an exterior door that is a requirement for a junior ADU, it's like wide open what you can do with JADUs. You're limited to 500 square feet. So the 80-20 ratio that you mentioned seems to me to be of concern, because if the energy code treats the junior ADU as an isolated separate unit, then even though the building code doesn't require, say, electrical separation, I'm wondering if the energy code is going to trigger additional remodeling requirements if someone just wants to convert say a bedroom and a bathroom in their house to a junior ADU for an aging parent or something like that. So that's mostly what I'm interested in, is how much construction work would be required as a result of the energy code if you're doing junior ADUs.
Yeah, with the junior ADUs, the whole idea is that they're to also kind of qualify, or junior ADUs, the way the energy code looks at it for alterations is you're doing that alteration inside the footprint of the existing structure. So unless you're also changing out all the windows or tearing off all the siding on the outside of the house anyway, or doing something radical like that, you're not going to be triggering too much of the energy code, except for maybe that new outside door that's got to meet the minimum, requirement. I think prescriptively on the energy code would be a pretty good way to go at that point. You'd show compliance with a few things that you're updating, and then you can deal with the other codes for some of your other changes. But if you're putting in a brand new bathroom, that new bathroom will need an exhaust fan, for example. Yeah, I hope that answered.
Yeah, great. Thank you.
Good. All right. And with that, I think it's a wrap unless there's any last questions. All right. Thanks everyone for being here.